this. Let me take this one here. Two stiff non-conducting rods have length L. Okay, these are the rods. Each and have small balls connected to their ends. These are the small balls. The rods placed parallel to each other and the balls are connected by two identical springs as shown. Okay, these are the springs. So what is the spring constant of that? Okay, I think I'll take some. So this will be the spring constant. Then, okay, there's a spring constant. Okay, now, and the balls are connected by two identical springs as shown. So these are the identical springs. When each ball is given a charge Q, the system stays in equilibrium. When it is in the shape of a square, the system stays in equilibrium when it is in the shape of a square. So here is what the square I have. If natural relaxed length of each spring is L/2, find the force constant K for them. Okay, I think you got it. The moment I release the system. So initially what happened, what is the state of springs? Both they are relaxed. Then the moment I release them, because of electrostatic force, so what will happen to the spring? It will get elongated. The spring will get elongated. Now, why do it get elongated? Look at the electrostatic force, how we have. Look at the electrostatic force. So this will be F12, why F12? Because I give number charges 1, 2, 3, 4. All they are like charges. So the F12 will be in this direction. Repulsive force. Similarly, F21 in this direction. Similarly here, F14, repulsive force. Similarly, F23. Then 1 and 3 like charges. So this will be F13. Then F24. Okay, got it. Okay, now finally they'll attain equilibrium. What will happen to the length of the spring? It will become square frame. Is telling that everything will become a square frame. Then how much elongation of the spring should be? L/2. Because earlier, what was the length of this one? Earlier the length was in fact equal to L/2. This is the idea. Now, what is the length of the spring? L. So what is elongation? Should be L/2. I think this is a very important part of the problem here. So if the spring is elongated, how the spring forces will act here. Then they are in equilibrium. For it to be equilibrium, what are the conditions? We'll write it. Okay, now we have from the electrostatics F12 equal to F14, F12 equal to F14, F21 equal to F23. So these forces must be of equal magnitude. Getting this one. Okay, now what is that K naught? K naught is what? 1 by 4 pi epsilon naught. I think this is very important. Because we do have K is a spring constant. K naught will be 1 by 4 pi epsilon naught. Fine. Now, after this, okay, let's come. Similarly, what about the forces acting along the diagonal? F13. F13 should be equal to K naught Q square by what is this diagonal length? L√2. So that is what here we wrote L√2. So square of that will be 2L square. So these are the forces. Now, spring force, what it do? It should balance F12 plus F13 cos 45. So what is F12? We'll substitute this value here. Okay. Then what is F13? K naught Q square by 2L square. This value here. Substituting and solving for K, we'll get the